Hello students, on this video I'm going to show you how to calculate principal square roots. So principal square roots, and then as we keep going I'm going to show you how to do cubic roots and nth roots as well. Okay, so the common expression, I'm just going to put a letter in here, the square root of x. So this is the radical sign, that's the radical sign, which is an operation, right? This means that we have to take a square root, just like we have times sign or multiplications, just like we have addition sign, just like we have parentheses, which denotes, multiplication, and the division sign as well. So this is the root sign, and once we take the root, that sign has to disappear, the root sign or the radical sign. Everything that's inside the radical sign we're going to call the radicand. That's the radicand, all the expression inside the root. Okay, and then this whole thing we're going to call the expression, the radical expression. Okay, so sometimes later on, right, when we have cubic roots or nth roots, just whatever that index is, or we're going to call this number index. Okay, and this is going to tell us the number of roots, if you want to think about it that way. Okay, the number of roots that you're taking to this number. Okay, so let's see how what the actual square root means. So if I have a square root of a number 9, what this means is that we are looking for a number that when you multiply it times itself, the result is going to be the radicand. Okay, so what is that number that when you multiply it times itself gives the radicand? In this case, 3, right? Because 3 times 3 equals 9, which is the radicand. So the square root of 9 is going to be 3. Okay, that's going to be the result. That's how you take a square root. Now if I have something like, I'll come up with another example, square root of 16, we are looking for a number that when you multiply it times itself 2 times, the result is 16. The result is the radicand, the number inside the root. And we're going to see that the result is going to be 4, right? Because 4 times 4 is 16. 4 times 4 is this number in here. Okay, square root of 25, I'm just coming up with numbers in here. Okay, square root of 25, the number is going to be 5 because 5 times 5 is 25, right? 5 times 5 equals the radicand. And then you can keep going, right? You can keep going into numbers. I'm just going to do square root of 4. I'm going to show you 3 different examples that you might encounter on this case. Okay, so square root of 4 is going to be simple. The number that you multiply times itself 2 times. To keep the radicand is going to be 2, right? Because 2 times 2 equals 4. Okay, but now what if I have a negative radicand? What if I have a negative number inside the radical sign? The same rule applies, right? So we have to multiply a number times itself 2 times so that we get the radicand. So in this case, I know this is not going to be, I'm just going to do the not equal. This is not going to be 2 times 2 because 2 times 2 is 4. And this is also not going to be negative 2 because negative 2 times negative 2, that's also positive 4. And I cannot do negative 2 times 2, even though that gives the radicand. These are not the same numbers. Those numbers are not the same number. It has to be the exact same number. So the rule is when you have negative radicands, it can be negative 4, negative 60, negative 100, negative whatever number, the answer is not a real number. So you can do an A, or you can do this symbol over here. I think this is how the handout shows it, which means this is not a 0, this is no result, right? Or no real number. No real number. Or you can also write not a real number. Okay, or if you want to write it as a set, just an empty set. Okay, so this applies for every single negative radicand. So it can be negative 16, the square root of negative 16. It can be the square root of negative 25. It can be the square root of negative 13, the square root of negative 100. All of this, they don't have any result because that's a negative radicand. So they never have a result for square roots. Okay, and the other situation that we might encounter is going to be when the negative sign is outside the root. So in this case we do have a result because we have to do the operations in the root first, right? The root is going to take priority in PEMDAS. So if I write PEMDAS, this is parentheses, or operations inside a parenthesis, and this is exponents, and this is also roots. Exponents and roots. Okay, they are the same operation, so once you do parentheses, you have to do the roots, everything that's inside the root. Okay, so in this case, I'm going to evaluate the square root first, so this result is going to be 2, and then I have a negative sign outside the root that is not applied to the root. Okay, so result on this case is going to be negative 2, and the same applies for any other root that has a negative sign outside. They do have a result. Okay, so result is going to be negative because this negative is outside, and then I can take the square root of 16, which is 4, and this is going to be my result. Okay, well, last but not least, I'm going to show you how to do PEMDAS into some of those expressions that contain roots. So the first expression that I'm going to show you is going to be 144, square root of 144 plus 25, and I'm going to show you the difference between these two operations. Okay, is the result going to be the same? Is the result going to be different? Does it matter which order we do the operations? Well, remember that we have to follow PEMDAS. Okay, so we follow PEMDAS. We have to do operations inside the parentheses first. Now, this radical sign also works as a parenthesis. This is a grouping symbol. Okay, so we have to think about this as something like this. Okay, all of those numbers are going to be inside a parenthesis. In this case, I just have those individual numbers, right? So I have to perform this operation inside the root first before I start doing anything on the left side. Okay, so let's go ahead and do that mathematical operation, which is 144 plus 25, and that should be 169. And now that I have only one number, I'm done with the parentheses. Now I have to do exponents and roots. Now I can take the root, so which is the number that when you multiply it times itself, you get 169, and that's going to be 13. Right. Of course, to find these numbers, you can play with your calculator, right? Do 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, and then you're going to be getting all of these numbers that have a perfect square root. We call those perfect squares. Okay, I'm going to talk about those in the following video. So 13 is going to be the result for the first operation. On this case, we're still going to follow PEMDAS, right? So I'm going to follow PEMDAS, operations inside a parenthesis. Looks like I don't have operations inside a parenthesis in this case. All I have is just numbers inside the radical sign. So there's no operation involved in there. And then the next operation that I'm going to do is going to be exponents and roots. So now I have to do those roots. So the first root, what is the number multiplied times itself, gives 144. The answer is 12. And then I have a plus, and then I have to do the second root. And the root of the square root of 25, that's going to be 5. And now I follow PEMDAS. There's no multiplication, there's no division, and now I can do the addition of these two numbers. Right? 12 plus 5, that's 17. And can you see that these two results are not the same, right? Those two results are not the same. So that means that these two operations are not the same, and you have to be careful into how you approach these results. Okay. The last rule for roots that might come in handy is when you have fractions in roots. So if I have the square root of 9 over 16, this also translates, this is a rule for square roots. When you have a fraction, when you have a product or you have a quotient, two numbers that are multiplying or that are dividing inside the root, this is going to be the same as taking the root of the top and dividing it by the root of the bottom. And it looks like it's going to be a little bit easier to approach this way, right? So the square root of 9, that's going to be 3. And the square root of 16, that's going to be 4. And the result is 3/4. And this makes sense with the rule, right? If I take 3/4 and I multiply it times itself, do I get this radicand over here? And the result, the answer is yes, right? 3 times 3, that's 9, and 4 times 4 is 16, right? So I do get the radicand that's inside the root. On the following video, I'm going to show you how to simplify expressions, algebraic expressions that contain letters and numbers, a combination of letters and numbers and exponents. And I really hope this helped a little bit.